Salam and welcome everyone. So today we're going to be working on a past question for a physical chemistry exam from one of my students at your university. And this was shared to me in order for me to tutor them. And I just thought it would be a great material for the students on my channel because it's still the same thing that I work on, the physical chemistry Atkins 11 edition. Although this question is not from there, but I've treated questions from there. But whatever the case is, please stay tuned and learn. So the question on the screen says, an isothermal compression decreases the volume of 1.5 moles of an ideal gas at 298 Kelvin from 540 centimeter cube to 330 centimeter cube. Given that the compression is reversible, how much work is done to the gas during compression? So, the first thing you have to do when you have a question like this is to reread it and to make sure you note keywords. We're told an isothermal compression decreases. So, from the first few words, we've seen the keyword. We have an isothermal compression question. Decreases the volume of 1.5 moles of an ideal gas at 298 Kelvin from 540 centimeter cube to 330 centimeter cube. Given that the compression is reversible. So now we've been given isothermal compression as well as reversible. How much work is done to the gas during compression? So we have isothermal, we've been told, which just simply means constant temperature. So meaning the process that we're solving for occurred at constant temperature. We have compression, okay, we means we have a decrease in the volume of the ideal gas. Okay, so meaning the V final is less than the V initial. So, and we're told that it's reversible. When you're dealing with an isothermal reversible compression question, then you know that you're going to be using this formula when you're asked to do the calculation for the work done. So, work done is now going to be negative nRT ln V final divided by V initial. So this is the formula we need to solve this question. So when we have that, we can compare that to the question and actually write out the parameters. So the parameters that we're given is just simply the number of moles. Okay, number of moles is just 1.5 moles. Okay, we've been given the temperature, okay, 298 Kelvin. And of course, we've been given the initial volume. This is such a straightforward question. By the way, I have other questions like this on my channel. So initial volume 540 centimeter cube, and then final volume is 330 centimeter cube. So we are now told to determine the work done. When you compare our work, the values we're given with the formula, we see we've been given the number of moles, we've been given the temperature, the initial volume, and the final volume. And of course, we know what R stands for. R is a gas constant, so it's a constant value, so we don't really need to worry about it. So now we have all of this. We know all we have to simply do is substitute. So W equals negative 1.5, okay, mole times gas constant 8.3145 joule per mole Kelvin. Now, I wanted to quickly mention something to you. We have two gas constants in chemistry. We have the 0.08206 and the 8.3145. Now, the reason why we're using 8.3145 joule per mole Kelvin is because our work done that we're given, that we're asked to solve for, I apologize, has its units in joules. So it would not make sense for us to use a gas constant where the units don't match with our final answer. So that's the reason why we're using 8.3145, because it has joules in it, and our final answer has to be in the units of work, which is also joules. So that's basically why we're using that. So now times R 8.3145 joule per mole Kelvin times temperature, which is just simply 298 Kelvin, times ln V final, which is 330 centimeter cube, divided by V initial, 5.540 centimeter cube. So all we have to do now is for us to cancel out everything we're supposed to cancel out. We cancel out the number of moles, cancel out the number of moles, cancel out the Kelvin, cancel out the Kelvin. So we have the joules still left here. Now we have to also look at other things that we're supposed to cancel out. Now, whenever you're dealing with a question that is enclosed in ln, just know that we don't actually have to convert the units of volume, because normally whenever you're dealing with joules, we're supposed to have our volume in meter cube, but you see in this case we did not convert from centimeter cube to meter cube, mainly because it is going to be like the same value because we're dividing it by each other enclosing an ln. It's just like as if they're asking you to find the ln of 4 over 8 as well as the ln of 1 over 2. The truth is 4 divided by 4, 1, 4 divided by 8, 2. ln of 4 over 8 is going to give you ln of 1 over 2. So you basically saying ln of 330 times 10 to the power of negative 6 meter cube. The 10 times 10 raised to the power of negative 6 meter cube can cancel out. So it wouldn't make sense for us to go through the process of conversion if we're still going to have the same information. So we can skip that step. So we're going to cancel out centimeter cube here and centimeter cube here. Cancel out the 0 here, cancel out the 0 here. So work done is now going to be negative 1.5 times 8.3145 times 298 Kelvin would give you negative 3716.5815 joules. And then you have ln 33 divided by 54 is the same thing as ln 0.611111. So when you input this entire information in calculator, negative 3716.5815 times ln 0.611111, work done ends up becoming positive 1830.3291 joules. So what this looks like is that you're going to be wondering, okay, why do we have a negative here and then now we have a positive? Note that ln of anything that is less than 1 is going to end up giving you a negative number, and ln of anything greater than 1 is going to give you a positive number. So in this case, what was generated here was negative, and we know negative times negative is going to give you positive. So this is just a mathematical explanation. But the second explanation is in the question, right? We're told that we're dealing with the compression. Whenever we're doing the compression, it means that the surroundings are doing work on the system. And whenever work is being done on the system, not by the system, work is being done on the system, there is an increase in work done or increase in energy of the system. So that's the reason why our work done is positive, because compression involve work being done on the system, thereby increasing the energy. So that's why we have positive. That is a thermodynamic explanation or scientific explanation of what's going on here. So yeah, that's it. Now you're going to be wondering, okay, well, we've gotten 1830.3291 joules. What is the next thing? Well, the next thing is for you to a roundup, because you go back to the question, we see that we have two sig figs here, three sig figs here, three sig figs here, three sig fig here. And the rule in science is that you're going to pick the significant figure of the lowest value that you're giving the question. So we have to put our work in two sig figs. So when we put our work in two sig figs, we end up with work done is equal to positive 1.8 times 10 raised to the power of 3 joules, or work done is equals to positive 1.8 kilojoules. So this is basically the answer to this question. If you have any questions, suggestions, or concerns, make sure you put in the comment section. By the way, for any of you who want me as a personal tutor and you're in middle school, high school, or college and you're trying to succeed, I am the tutor for you. I have students succeed in all your STEM related courses. And if you would want to know more about my services, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Do not forget to ask all your questions and do not forget to push through your time in university. I wish you guys again all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.